Hiya, it's Mr. Baker here, and today we're going to be looking at distance and speed. Okay, so we're looking at distance and speed today, and we're going to be answering this question: what is speed and how can I calculate it? Okay, so we're going to play a little game to start off with. We're going to see if we can guess how fast these different things are. So what do we mean by speed? What I want you to do is match each animal to its top speed. Okay, so we've got a node of top speeds here. I want you to guess what they are. Okay, so cheetah over short distances, how fast can that go? I'm going to show you the answer straight away, so have a little guess. Shout it at the screen if you want to, or just write it down, or just think it in your head. Right, and it is 110 kilometers an hour. Did you get that one right? I don't know, I can't hear you. Right, next. A sailfish in the seas around Florida. So how fast is the top speed of a sailfish in the seas around Florida? I don't know if it's different if they're in different seas around different places. No idea. 110 kilometers an hour. Wow, was that the same? That was the same as a cheetah. Wow, that's fast, isn't it? Okay. An earthworm in a hurry, being chased by is that a robin? I don't know. Some kind of bird. Although the bird doesn't actually look like it's even seen the worm there. I don't know what's going on. Okay, but how fast can it go? 0.005 kilometers an hour. Did you get that one? Okay, so not as fast as a cheetah, surprisingly. How about a tortoise in a jet plane in first class? Hilarious. So how fast can that go? I don't know. I suppose if it's in not first class as well, if it's in the same plane, surely it'd be getting the same speed. I don't know. So 800 kilometers an hour. Did you get that one? And then what about a peregrine falcon in a dive? 350 kilometers an hour. So before we move on to looking at the rest of the lesson, we really need to define a few things. We need to know what the difference is between something called scalars and something called vectors. So distance and speed are both scalars, so they have a magnitude only. So if you think about what distance is how far you go. You can measure it in meters, you can measure it in miles, you can measure it in centimeters. I can go 50 miles and I can go 50 miles in a round journey back to my house. But I've gone 50 miles. It doesn't matter which direction I've gone, or I could go 50 miles and go straight line, and I still would have gone 50 miles. I'd end up 50 miles away from my house. Same as speed. If I'm travelling at 10 meters per second, I could be running 10 meters per second round in circles, not getting anywhere. Or I could run 10 meters per second in a straight line, and I could get somewhere. But it doesn't matter. I just describe my speed by how fast I'm going at that time. So 10 meters per second or 30 miles an hour, whatever it might be. Okay, so it just has a size, just the actual value of how big the thing is. Whereas displacement and velocity are both vectors. So they have a size. I need to describe how big those things are, but so a magnitude. But they also have a direction. So if I said that I've got a displacement of 50 centimeters, I need to say that that's 50 centimeters up or 50 centimeters north, or whatever it might be. Same with velocity. I need to describe that the velocity is, say, 20 meters per second to the east, or 20 meters per second straight down. I've got to have a size and a magnitude, and I've got to have a direction. So the way we describe these things then, speed is the distance travelled in a certain time. So it's just the distance in a time. Velocity is speed in a given direction. So it's the same, it's the distance travelled in a certain time, but in a certain direction. Okay, so those two are really important. You need to know the difference between them. Okay, just to make sure that you've got that then. So how is velocity different to speed? So the speed of an object does not depend on the direction in which it is travelling. The velocity of an object is the speed and the direction in which it is moving. So this car is travelling north with a velocity of 10 meters per second. So its speed is 10 meters per second. Its velocity is 10 meters per second north. If it goes around a corner, the speed of the car would remain the same, but the velocity would change. So as it goes round the corner, the speed can stay at 10 meters per second, so it's still the same value, but the velocity must have changed because it's not going in the same direction anymore. Okay, so that's the difference between speed and velocity, vectors and scalars. Okay, so how can we calculate the speed? So how do people work out the speed of animals? We use this equation. Speed equals distance divided by time. So you need to know the distance travelled and the time it took to travel that distance. So we looked at an earthworm before. We've got an earthworm moving 5 meters and it travels a certain time. What's the earthworm's speed? So we'd look at the change in time, we'd look at the distance, and we go distance divided by time, and you would also, you need to be careful about the right unit. So if it's gone 5 meters in 3 hours or whatever it is, 4 hours, then you would go 5 divided by 4, 1.25 meters per hour. Okay, so that's how you would describe the thing, and you've got to be careful of what the units are that you're using too. Okay, so speed is how far something travels in a certain amount of time. So we've got our equation. Distance, normally we would use meters for distance and we'd use second for time. So the SI units, the Standard International units. So the unit of speed is meters per second, the unit of distance is meters, and the unit of time is seconds. So we've said that speed is distance divided by time. We could, if you would like, you could use a triangle maybe to help you to work this out. So you've got to be able to work out speed being distance over time, but you've also got to work out what distance and time are. So one way that you could use is one of these triangles. So if I want to find this out, then I would cover over speed, it's distance divided by time. If I wanted to find out distance, then I'd cover that over, and it's speed times time. If I want to find out time, then I'd cover it over, and it's distance divided by speed. So the thing with these triangles is you've got to have a way of remembering where these are. So S, D, T, you've got to think of a way that you know that distance, the D is at the top, and then the speeds are, it doesn't really matter which way around these two are, but just so the speed and the time are down the bottom. Right, another thing that you need to know is roughly how fast do sort of common things go. So when we're walking, we walk at about 1.5 meters per second. So this little squiggly line kind of means around about. So walking, we move around about 1.5 meters per second. If I was to jog, maybe I'd go about 3 meters per second. And if I was cycling, maybe I'd go about 6 meters per second. So obviously there's a range. Not everyone's going to walk exactly 1.5 meters per second or jog exactly 3 meters per second. But around about, those are the kinds of things that you should have in your mind. So if you are asked a question, how far has somebody gone if they went for a walk and they walked for 10 seconds, then you'd know that 10 seconds, every second they're going 1.5 meters. So 1.5 times 10, they would go 15 meters in 10 seconds, perhaps. Okay, but yeah, they're quite important just to remember those estimates of how fast things go. Okay, let me go through a couple of examples with you before I leave you. So here we've got Usain Bolt. He can easily run 100 meters in 10 seconds. What was his record? 9.58 seconds or something, was it, for 100 meters? But anyway, he can run 100 meters in 10 seconds. So what's his speed? So first of all then, write down all the stuff you know. I know that the distance is 100. I know that the time is 10. And I know that speed is distance divided by time. Then I put those things into my equation. Speed is 100 divided by 10. The speed is 10 meters per second. Okay, how about this one? A car travels at 40 meters. Travels 40 meters in 2 seconds. What's its speed? So the distance is 40 meters. The time is 2 seconds. We know that speed equals distance divided by time. So you put those into your equation, and we work out that speed equals 40 divided by 2. The speed is 20 meters per second. Okay, so they were fairly straightforward. One way that we can make this slightly more difficult is instead of using seconds, we could use minutes. So here's an example. A car travels 25 meters per second for 3 minutes. So how far does it travel? So we know that speed is distance divided by time. So we could rearrange our equation using the triangle or just by rearranging it, so that that's distance equals speed times time. So 25 meters per second, that's our speed. We've got to change the minutes into seconds, so we know that there's 60 seconds in a minute. 3 times 60 is 180, so the distance is speed times time, 25 meters per second times 180 seconds, so it'd be 4,500 meters. So that's the lesson pretty much over. We've looked at distance and speed. So if you just want to have a look at what you can do today then, so you should be able to define the difference between speed and velocity and distance and displacement, looking at what the difference is between scalars and vectors. You should be able to estimate typical speeds for walking, running and cycling, and then you should also be able to calculate the speed of an object. You should also, as well as being able to calculate the speed, you should be able to calculate distance or time by rearranging the equation. And you should know the difference between speed and velocity specifically. Okay, right, well, I've been Mr. Baker. Thanks very much for watching it. That is the lesson over, and I will see you next time.